Well, it's always, it's really not that hard to get me back to Cedar Rapids. It's always good to be back here. Some of you may know that I began my career here some almost 34 years ago. When I was a young EE, just graduated from the University of Illinois, came to work here at Collins. Collins was in an independent company, and I, 22 years old, and went right to work on Project Gemini, building a radio for Project Gemini. And I've told people it took me 30 years to get back into the space business after that, as I worked in electronics most of that time. Things have changed a lot for me since then, both in the business world, of course, as well as on a personal front. I haven't been an active engineer for, I guess, close to 20 years, the way I would view it. But I am still a EE at heart, and I'm very proud of it. And I'm real happy to be here with you today. As you might expect, not having been in a EE for quite a while in terms of practice, I'm going to talk about engineering from more of a management perspective today. In the printed program that I think you all received, they give it a rather stuffy statesman-like title about an industry perspective, change, and challenge. But the truth is, what I want to talk about might more accurately be called, how do we get more bang for the buck out of engineering? But before I get into that, let me review a little history, a history that I personally watched, as many of you in the room did as well, of what we went through in this country and in the world of technology over the last 30, 35 years. You know, as we got into the 60s and maybe even the early 70s, it was clear that the economic strength of the United States depended in a very large part on U.S. technology strength. We were in the Cold War back in those days. We were in an arms race with the Soviet Union. We were in a race to the moon back when I started my career. I remember the election of 1960, where the big issue was the missile gap. Remember that? What was the gap in the missile capabilities of the Soviet Union versus the U.S.? The United States had massive manufacturing capability in those days, a strength probably built from the arsenal democracy thing we had going in World War II. It was clear in those days that a large part of the bill for R&D was paid by the government, mostly defense or NASA. And it was great. Those were great times because America was the leader in almost everything. I mean, including automobiles, consumer electronics, telecommunications, whatever the product was, America was generally in the lead. As we got into the later 70s and the early 80s, it became obvious that we were losing that leadership in many sense, particularly in the global commercial marketplace. The balance of trade for the U.S. was worsening, and we were being outrun in the race towards affordable, reliable products. We clearly lost the leadership in consumer electronics. Many would say at the same time we lost our leadership in automobiles. Our technology base was still strong, but it appeared that we were losing some of the process discipline or business and management discipline in the R&D community. Or some would say we really never had. We never were as good as we thought we were in those days. Because we would look and see, how can the Japanese develop and produce such low-cost products? As we watched the astounding price cuts in consumer electronics. And I remember in the management world of the early 80s, late 70s, the conventional wisdom in management was, don't even try to compete with the Japanese. Just abandon those segments of the market and let them happen, because you're going to lose money. You can't compete. A high percent of our R&D was government sponsored. Government spending in defense, NASA, energy. By that time, we'd won the moon race. We were still in a tough competition with the Soviets, still neck and neck arms race, and they were spending, some would say, 20% of their gross national product on defense, forcing us to spend a huge portion of our own. Many were saying that this focus on defense and space were a basic cause of our demise in consumer electronics and things like that. because all of our best talent was tied up in these defense projects. And it was about this time, as I recall, that a few Americans invented something called a personal computer, which was to revolutionize the world we live in today. But it wasn't viewed probably as too significant at the initial years of that. So we go then to the middle 80s up to the present. I would say that about then was when the turnarounds began. We started to really understand what our problems were. Industrial companies now, driven by fierce foreign competition in every field, basically, work to improve the effectiveness of their engineering processes by factors of 2 or sometimes even 10 times compared to what they were before, by focusing on the engineering and manufacturing process disciplines. I remember a quote, again, when I was a young manager that stuck with me. Somebody once said, and I don't remember who it was, the biggest problem facing American business is the size of the U.S. market. And that meant that we weren't used to having to compete globally with foreign competitors. Our market was often, like in telecommunications, is half the world market. So companies were most content to just focus on the local market and forget about the rest. This was one of our problems. Focus on processes became important, and I think that's been a part of our salvation. The term TQM, Total Quality Management, was invented around that time. I'm not sure by whom, but this, of course, was the concept of focusing on the elimination of non-value added steps in all of our processes, our process steps. The idea of statistically analyzing the problem or in determining what the defects are or the problems are, and then systematically attacking them one by one based on the most important first and so forth. We started to learn about a whole bunch of new tools of simulation and analysis, modeling. We started viewing engineering and manufacturing as one integrated process rather than two worlds with a barrier in between. We started to use integrated product and process development teams, things like self-managed work teams. All of these things contributed to our progress, I believe. We started seeing lower cycle times, higher quality products, higher manufacturing yields, costs coming down, and most importantly, improved performance and reliability in the eyes of our customers. I think this lean management process that we started to call it also led to improved or closer customer interaction, really understanding what the customer wanted and trying to satisfy it perhaps before he fully knew what he wanted. Faster decision making, time and speed cycle time became an important metric in business. And these new tools that we got along this period also allowed us as engineers to design it right the first time instead of doing it over a couple of times. Again, throughout much of the 80s, the technology development, as well as a significant portion of the tools of the engineering and development manufacturing processes that I mentioned, again, were funded directly or indirectly by government resources. Again, defense, space, DOE, others. We saw programs like the manufacturing technology programs, DOD called it ManTech. DARPA had a whole lot of projects that were helpful. Computer-aided engineering and software tools like CASE and CATIA and so forth came on the scene. And the Defense Department, to its credit, adopted TQM as a philosophy, trained itself on it, and pushed it in business world, frankly, even before many of the commercial businesses were ready. And again, the government sponsored much of the R&D. And I don't dispute for one moment that sponsorship was an important and a necessary part of our progress. But industry was also contributing very heavily. One of the negative things we had in those days was that the government tried to impose legal and regulatory barriers between defense and the commercial world. Things like if you did what they called IR&D, independent R&D, as a defense contractor, they tried to make sure you couldn't take advantage of that over on the commercial side. You weren't allowed to give that information to the commercial divisions if you were a multi-industry company. Well, communications and knowledge awareness are not perfect, of course, in the technical community, as all of you well know, but it ain't bad either. And so there was a good deal of dual-use technology developed even before that term became popular recently. And by the way, it's interesting to note that the personal computer has not gone the way of consumer electronics. American manufacturers still control over 2/3 of the world market for PCs. And why does that happen? Well, I think it's happened because of the things I was just talking about, all the skills and ways of managing the processes of engineering that we've learned in the ensuing period. Things on focusing on processes, the integrated manufacturing and engineering teams, the new tools, many other things. I have to note here that the PC revolution has been great for my company, Rockwell. Over the past decade or 10 years, we've grown the modem business. Some of you are probably familiar that we provide some 75% of the world's modem chips for PCs and fax machines and that sort of thing. That's gone from a $50 million business in 1984 to an $800 million business today, just in those chips. And I always marvel at we've had one thing that sort of stayed standard. Most products, as you know, evolve and add features and capabilities as the price goes up. There's something called a Group 3 fax modem, 9600 baud modem, which has stayed functionally almost constant for the last 10 years or so. And that product's gone from over $1,000 in the late 70s to $300 in the mid 80s to $10 today. You just think about it, if everything we bought made that kind of progress, what our cost of living would look like. At the same time, the PC modem is gone. I remember when I first got my PC, I had a 300 baud modem. Today, of course, we have 28.8 V34 modems. So that brings us up to today, looking forward. I want to show you just a few charts to illustrate some of the points I want to make about R&D and some of the trends we're faced with. You know, back in the mid-'80s, we'd learned how to compete, we'd learned new techniques, we were regaining market shares and still are. Well, what threatens us today? Well, many would say it's this, that the government support for non-defense R&D is going to decline with the disastrous consequences. And no question, based on the current congressional budget resolution, government R&D spending, and this is non-defense, will come down fairly dramatically over the next 7 or so years. In fact, after inflation, adjusted for inflation, we would, if these numbers were to come to pass, we would invest about $11 billion less a year in the year 2002 than we are today, a decline of about 1/3. But let's look more closely at this. And I pulled some data out that's not on the chart. If you look at start with this baseline of let's say 33 billion over on the left today. 12 of that is in healthcare, in National Institute of Health and so forth. That's going to go from 12 to 9 over that period. NASA's going from 10 to 6. DOE's from 4 to 2. Ag, commerce, and interior altogether are going from 3.5 to 2.5. Transportation, 0.7 to 0.4. EPA, education and labor, are nits, and they don't even make it on the scale. But probably the most important one, the National Science Foundation, is $2.5 billion of this, going to about 2.1. Now clearly, I don't think we should let that go down, but I don't think the sky is falling either. Now, according to the Commerce Department, those proposed cuts that I'm showing here would eliminate 35,000 scientists and engineers from the U.S. R&D enterprise, and of course would affect university and private labs and research facilities across the country. Well, that's one view. And of course, these statistics are generated by the administration, who opposes the actions of the Republican-controlled Congress, who wants to cut spending. So you have to look at all of these things through two sets of eyes. Let's take a look at the commercial spending by U.S. industry. And I pulled together some data for hold that one just a minute. Industrial Research Institute, which just this month came out with a survey on R&D spending. U.S. industrial R&D in 1995, according to their numbers, Would you go back to the last slide for a second? I want to compare to this. U.S. industrial, in other words, our companies, all the companies in the United States, invested about $120 billion in R&D in 1995. And that is declining slightly. It's gone down slightly in constant dollars from 1991. But it's about 4 times bigger than the government sector. And that's something we need to keep in mind. In fact, the U.S. industrial investment in R&D is about 1/3 of the world total. As U.S. industry spends about an average of 3.5% of sales on R&D, and as all of you probably know, in the electronics industry, it's much, much higher than that. Industry spends about 3/4, 72% of their money on development for new products, about 1/4 on applied research, and about only 6% on basic research. And that's an issue that we should be concerned about. I think we need to push that number up. But even at 6%, it's still over $6 billion, maybe 2 to 3 times what the National Science Foundation funds. So we need to keep these numbers in perspective. Now give me the next chart. This is of concern. Focusing, and I'm going to be a little confusing, this chart changes scale on you. This is 87 constant dollars, whereas the last chart was $95. But as you can see here, Japan and Europe are in a positive trend while we're going down, and that is of concern, and I think we need to focus on that. Here you see the absolute dollars of non-defense R&D. The first 3 bars are history, of course, for 81, 88, 95, and the last set is the projection for 2002. Japan alone plans to double their government spending for R&D by the year 2000. So that's not a very encouraging trend for U.S. And unless U.S. industry steps up to their level of investment, which I think they must, we are going to be having some problems. I think good news is, according to this same survey by Industrial Research Institute, 27% of the companies that responded in a survey they just took do expect to increase their spending next year. And I think that is very important, and it's very important that that in fact happen. Now, there are the companies that are cutting expense, or expanding. Go to the next chart, please. And this is of concern to me, and there probably are specific reasons for each of these. I will point out that during this period, which covers 91 to 94, we've been going through a mild recession in the United States. But this is of concern, and I think U.S. industry must step up to fill the gap if the government's going to cut their investment. Now, going back to my own company, I'm proud to say that we've actually been increasing our non-defense investment in R&D while we've been holding defense R&D about constant. Of course, the defense market is shrinking each year, so we've been holding constant there while we increase our investments. In fact, looking at our electronics businesses in Rockwell, we're going from about $500 million in 1996 up to over $700 million by the year 2000. And there are many others that have been increasing their investments as well, companies like Motorola, Hewlett-Packard, and many of the new high-technology companies like Intel and so forth. Data that I've seen indicates that in the electronic field, it's typical to spend 8 to as much as 15% of sales in R&D as contrasted to the 3.5% for industry overall. So as I said, some of these numbers are very alarming. I think there is a reason for hope, provided we can motivate the U.S. industry to continue their levels of investment and increase those levels of investment. Now, I noted the issue you have on the board out front about encouraging Congress not to cut so severely, and I agree with it. We should do that. But it's equally important that we encourage Congress to do things that will encourage industry to invest more, things like the R&D tax credit, keep that maintained, and the capital gains tax, and reform of our legal systems, which burden us with so much risk on some of the technology issues. So regardless of your views on what the government role should be, I think it's clear that it's important that we in industry continue to invest. But regardless of where the money comes from, what else do we need to do? Regardless of these pressures, how can we get more done? How do we get more bang for the buck from whatever dollars we have? And I think as any problem, the first part of the answer is to clearly understand what the problem is. And I think part of that is just what I've been doing. We measure what goes in, not what comes out. We're all measuring how many dollars go into the process. What we need to focus more on is what are we getting for those dollars? How do we get more for those dollars? How do we focus on things like the exact product or program that comes out that has the competitive features that make the product a success? As I indicated earlier, one of our first steps to improving engineering and efficiency and productivity is to ensure that the engineering team is doing the right things. Are the customer requirements well defined and understood? Is the competitive posture recognized? Sometimes we fall into the trap. We got this great new idea for a product, and we forget about the fact that the other guys out there are not standing still either. They're moving forward with some new product of their own. And here's another one that I'm really hung up on. How can we reuse, at least partially, some of the hardware and software that we've invented in the past? And I'm going to come back to that subject. Are there project plans in place to use the best resources, regardless of where they are? In other words, do we let NIH get in our way? And I can tell you that we at Rockwell do fairly often. In other words, the division that's got the project wants to do all the work, when in fact there probably is a sister division or an outside company that should be doing part of that work for them because they're more proficient at it. I'll give you an example of that. We're working in one of our West Coast divisions on a satellite program. This satellite required a couple of ASICs be designed for this satellite. The team, who were really satellite builders, decided to do those themselves. And as you can imagine, they got into all kinds of trouble and way behind schedule and cost because of that, where they had sister divisions right across town, literally, that do that every day and could have done it more effectively. And we've got to find a way to do those kinds of things. These things, of course, a lot of these things I'm talking about are engineering management issues, but I think that's where the overall process of improvement needs to start. The recent article I saw a study of the autopsies of a significant number of program failures. And a number of companies revealed that the principal reason for failures of the project were failure to identify up front what the real requirements were and get that well defined before we started. So obviously, in addition, we've got to be using the best tools, recognizing engineering as being part of the total team and making them part of that team, using tools like integrated product and process teams that attack both the process and the product simultaneously, and recognizing the need for a design to requirement. And usually in the commercial world, of course, that's cost. Because there's more times, so many times you see where time or schedule is the excuse for not doing it right. And we don't have time to do it right, but we have time to do it over. So I'm really hung up on this issue of having more of the effort up front. As I mentioned, hardware and software reuse. I think this is a problem where we in America have a problem about being willing to do this. I recently saw a company that we were thinking about acquiring, which had a very well-established and disciplined process of looking at reuse, which I was impressed by. I've always been impressed by the Japanese consumer electronics folks who have a regular practice of reusing and just iterating designs rather than starting all over. Back when I was in the telecommunications business 4 or 5 years ago, one of my customers was telling me about how my product stacked up against a Japanese, this happened to be a microwave product. And he said, you know what I noticed as I look at what you are doing and what your competitor's doing is that every time you come up with a new product, you totally start over from ground zero. It's a totally new product, new power supply, new chassis, new everything. Whereas your competitor just continually upgrades one element at a time. So I think that's a lesson we need to think about. We need to communicate better with our engineering people and make them a part of the team, as I mentioned. We've got to provide the resources and facilities for lifelong learning, and encourage and make easy for lifelong learning. I've heard it said many times that the half-life of an engineer is 5 years, and it's getting shorter. I think that's probably true. We got to give you the resources you need, the tools that I mentioned, particularly software tools. We need to give recognition. Oftentimes that's not financial. It needs to be financial, certainly, but also it needs to be non-financial. One of the programs that we have at Rockwell that I'm particularly proud of is our Engineer of the Year program, where we pick one engineer from each major business to be honored in a dinner with the chairman and everyone each February. We've got to make people aware that they're not isolated. They're not sitting over here in Iowa or New York or California all by themselves. They are part of a team that's competing against a whole bunch of other teams all over the world who are trying to take away the same business and make them have a greater awareness of that. And I think also we've got to find ways to, in the bigger companies, it's not true so much of the small companies, but in the bigger companies, to get this interdivisional thing to work better, where we can take a skill in Division A and mix it with a skill from Division B and then go after something that we otherwise wouldn't be qualified to do. And the final management issue I want to touch on today, I can have the last chart, thank you, is this issue of balance between functional excellence and integrated product team approach. Perhaps 5 years ago, I will not say perhaps, I will say definitely 5 years ago, we had too much focus on the functional side of things and not enough on the integrated team approach. Today, I'm concerned that we may have tipped the scales a little too far on the team side for this reason. I'm seeing evidence that the functional engineering disciplines are breaking down in some cases. These teams are getting so divorced from those seasoned managers who are the engineering management structure that they're losing touch with them. We're having younger engineers in particular who haven't had the seasoning on their own, and they need to be able to tie back to that older, more experienced boss of theirs. So I think we need to rebalance that just a little bit for the future. Most of what I've just covered in terms of improving the bang for our buck it will clearly, I think, increase our competitive posture and allow our business to hire more people and provide more stability for the folks that are working today. But there's another vector for growth I think it's important too, and then besides maintaining and staying competitive in the businesses we're in, and that's then building new businesses. One of the encouraging statistics that's coming out of California in this last year, and we all know how badly California's been hit by the aerospace cutbacks of the Defense Department and NASA, that at the same time there's a lot of employment downturn in those areas. We're seeing statistics on significant growth in new venture startups. And it's in those new venture startups where the issue of capital formation, of capital gains tax reform is so important, because that's where we're going to get a lot of our new employment base. New ventures can be grown outside of the venture capital world. They can also be started inside of the bigger companies like the Rockwellers, the Hewlett-Packards, by pulling together people who can address new markets. We have a thing we call the Rockwell Growth Initiatives Forums, where we meet about once every 2 months with a group of technical people and business people and just kick around ideas, principally focusing on things that no one division would normally go off and do on their own, but where is there an opportunity to bring together more than one division to create a new product. I think, sort of in closing, that it's our responsibility, both as individuals and as groups like the IEEE, to influence lawmakers, to encourage the laws that are needed to support the appropriate level of government R&D and not let it be cut too far, because it is a part of our essential growth engine. Also, increase to support things like the R&D investment tax credit and the capital gains tax, regulatory reform. And clearly, university research effectiveness is vitally dependent upon the National Science Foundation funds, as well as that contributed by our companies, and that has to be increased to offset that. As you can probably tell, I do believe in the incredible power of the free enterprise system. the motivation of individual ownership to create new ideas and invest and come up with new products. That's where the real growth of employment and professional ranks comes from in this country. We have an unbelievable productive capacity of our U.S. industry, and it's that productive capacity that ultimately beat the Soviet system and brought it to its knees. And that's what freed the Russian people and the people of Eastern Europe of communism. And you and the fellow engineers that you represent here today were a big part of that. And I know I'm very proud of the role that we've all played as an engineer, and I hope you are too. In conclusion, let's not forget that all engineers do owe a commitment to their profession, to their countries, to the world, as well as to the individual customers and employers that we work for. We need to work to improve education and training, both on the job and off, improve the professional standards of excellence, improve the non-competitive interactions like IEEE sponsors to enhance the technology and engineering processes. And I think your involvement in IEEE is evidence of your interest in such a contribution. I have to say that I think we live in the greatest country in the world, and that owes its very freedom and its standard of living to creative people like yourselves. So let's all try to put something back into the system that's done so much for us and for our country. Thank you for inviting me today.